Good evening, our students, and welcome to this discussion. Today and this moment, we have come up with a topic to discuss with you in details. And that topic, of course, is what we call chi-square test, or what is called chi-square test. So we have questions to raise and then answer it on the course of discussing the lesson. And these questions are: one, what is a chi-square test used for? Or what is a chi-square test? When is it appropriate that we resort to using chi-square test as a tool for data analysis? These are very two strong questions that we feel that at the end of these discussions, we must have provided answers to. So what is a chi-square test? The simple explanation of what chi-square test is that it is a tool, a statistical tool or measure that is used to determine and compare the differences between the observed frequencies and the expected frequencies from a data set. There are key words in this definition. These keywords are determine and compare, and equally observed and expected. So anytime we talk about chi-square, these keywords should be before us. We should be talking about our observed and our expected frequencies. We should be talking about determining and comparing the differences between these two quantities, which are the observed frequencies and the expected frequencies. Chi-square test as a tool for data analysis is classified into two. Number one, we have what we call chi-square goodness of fit tests. And number two, we have what we call chi-square test of what? Of independence. So we are going to discuss what we call types of chi-square tests. Types of chi-square tests. Types. Number one, we have what we call chi-square goodness of fit tests. Chi-square goodness of fit tests. And number two, we have what we call chi-square test of independence. Number two, chi-square tests of independence. These are the two classes of chi-square tests, and both of them do make use of expected and observed frequencies, and equally try to determine and compare the differences between these two quantities. So our major concern now becomes, when is it appropriate for us to resort to using chi-square goodness of fit test? And when is it appropriate for us to resort to using chi-square test of independence? So by a way of answering these questions, we are going to explain chi-square goodness of fit test and equally explain chi-square test of independence. Chi-square goodness of fit test is a statistical tool or measure that is used to determine how well our model fits the observed data sets. That is to say, that when a model is fit to a data and we want to determine the adequacy of that model, the appropriate test that is used here is what we call chi-square goodness of fit tests. it is used to determine how well the model fits the observed data. And you know that if a model fits a data well, the predictions that are made from the model will be very close, if not exactly, with the observed frequencies. Therefore, the implication of this definition or explanation of chi-square goodness of fit test is that it is used to determine how the predicted values from our model match the actual observed values of the data set. That is what we call chi-square goodness of fit tests. If you go through the pages of textbook, you equally run into another explanation of chi-square goodness of fit tests. And we have deemed it wise to equally explain that definition. Some people say that chi-square goodness of fit test is a statistical tool or measure that we use to determine if a set of observation comes from a particular or a specified distribution or not. That is to say, that we might have a data set, and the interest is to determine if this data set we have is coming from distributions like binomial distribution, Poisson distribution, normal distribution, and the rest of distribution. When we have situations like this, trying to determine how well our model fits the data, we resort to chi-square goodness of fit tests. When our interest is to determine if a set of observation comes from a specified distribution, we resort to what we call the chi-square goodness of fit tests. Now, we are equally now going to give what we call, if we have known that the chi-square chi-square goodness of fit test is used in these conditions, we ask ourselves, what is the test statistic for the chi-square goodness of fit test? What is the test statistic, or what we call the formula for the chi-square goodness of fit test? The formula is given this way: that chi-square, which we are calling chi-square calculated, and we write it chi-square cal, is given as sum over I of O subscript I minus E subscript I all raised to power 2 all over E subscript I. And this chi-square cal follows a chi-square what distribution? It follows a chi-square distribution with k minus 1 degrees of freedom, or with k minus 1, k minus p minus 1 degrees of what? Of freedom. We are going to explain. The formula with which to calculate the chi-square goodness of fit test statistic is sum over I of O subscript I minus E subscript I all raised to power 2 all over E subscript I. And this chi-square test statistic follows a chi-square distribution with k minus 1 degrees of freedom, or with k minus p minus 1 degrees of what? Of freedom. Where we now say where our O subscript I is the ith observed frequency. Ith observed frequency. Observed frequency. Our E subscript I is called the ith expected frequency. Ith expected frequency. Expected frequency. Then our K here is the number of classes that our data set is arranged into, or what we call number of categories of the data set. Number of categories or classes. Number of classes or categories. So by implication, for us to talk about chi-square goodness of fit tests, we must have to first of all arrange our data set into categories or into classes. So it must be a categorical data. Then our P here is number of parameters that is estimated from the data set. Number of parameters estimated from the data sets. Okay? So the next thing that is before us here now is that we are going to give a general guideline that one ought to follow to logically arrive at the conclusion of a chi-square goodness of fit test. That is, first thing first, second thing to be second, down to the what, to the last stage, which we call the procedures of conducting chi-square goodness of fit tests. Step-by-step procedures of conducting chi-square goodness of fit tests. So permit me to clean here. For us to conduct a chi-square goodness of fit tests, the first thing we are going to do, which is the step one, is to state the hypothesis. State the what? Hypothesis. That is number one. Number one says state the hypothesis. The hypothesis. This hypothesis comprises of the null and the alternative hypothesis. The null and the alternative hypothesis. Null and alternative hypothesis. Null is stated like saying that the data set follows a uniform distribution. The alternative will say the data does not follow a uniform distribution. Then number two we are going to do is to state the level of significance. State the level of significance. That is alpha, which of course is the probability of committing type 1 error. What is type 1 error? Rejecting a true null hypothesis. Then number three, arrange the data set into K categories or into K classes. Arrange the data set. Arrange the data set into K categories or classes. Okay? That is number three. Number four, calculate the expected frequencies of each of the class. Calculate the expected frequencies of the classes. Then number five, obtain the chi-square goodness of fit statistic, making use of this formula. That chi square cal equals sum over I, O subscript I, E subscript I, all squared, all over E subscript what I. Okay? Use this formula now to obtain the chi-square goodness of fit statistic. Permit me to clean here. What is number 6 that we are going to do? Number 6. Determine the degree of freedom. Determine the degree of freedom using k minus 1 or k minus p minus 1, depending on if we estimated parameters before applying to our formula. If no parameter was estimated, we make use of k minus 1, where k is talking about number of classes. But if parameter is estimated, we talk about k minus p minus 1. What is the seventh thing we are going to do? Number 7. We now say, obtain the critical value of the chi-square goodness of fit test using the critical value. Using chi-square of what? Of alpha of k minus 1. Or chi-square of what? Alpha of k minus p minus 1. Use this formula to obtain the critical value from what we call the tabulated value of chi-square distribution. That is from the chi-square table, where this alpha might be 0.05 or 0.01. If this our k is something like 8, we now say 8 minus 1, we have 7. We locate the degree of freedom of 7 and then the level of significance of 0.05. And that will give us now the critical value of the chi-square goodness of fit test. What is the number 8 thing that we are going to do? The number 8 thing we are going to do is, number 8, compare the chi-square calculated and the critical value of the chi-square test. Compare the chi-square cal with the critical value of chi-square. Critical value of the chi-square. Critical value of the chi-square. And then determine either to reject or do not reject H0, called the null hypothesis. And of course, we can only reject our null hypothesis if the chi-square cal is greater than the chi-square tab, or which we call the critical value of chi-square. Critical value of chi-square. We can only reject if this condition is satisfied, that our chi-square calculated is greater than the chi-square tabulated. And in that case, we are saying that our chi-square calculated has fallen into the critical value of the chi-square distribution. And for that reason, we are going to reject the null hypothesis, which says that our data set comes from a particular or from a specified distribution, or that our model is adequate. These are the steps which one must logically follow if one must arrive at valid conclusion using the chi-square goodness of fit test. As a word of recap, we just introduced chi-square, told you what it is, told you about types of chi-square in terms of chi-square goodness of fit test and chi-square test of what? Independence. We now decided to elaborate on chi-square goodness of fit test by giving you the explanation that it is used to determine how adequate the model feeds the what? The data, or how well the model feeds the data. We equally told you that it is used to determine if a data set comes from a specified distribution. We now went ahead to tell you that the chi-square test statistic for goodness of fit is given this way. At the end of which we went ahead and told you the steps that one ought to follow if one is conducting chi-square goodness of fit tests. This is just the introductory class into chi-square goodness of fit test. The next class that is coming immediately that will be tagged on YouTube as chi-square goodness of fit test 1 will be when we should be taking real life examples and be solving with you. This one on YouTube will be tagged the introductory aspect of a chi-square distribution. Thank you, and stay tuned for the next class that is coming your way immediately.